All right. Well, welcome everyone to the September 14th SIG Node meeting. Mine of the meeting is recorded and will be later updated to our YouTube channel for folks who can't attend today. I don't know, Sergey, if you want to give a summary on where we are with respect to the incoming and outgoing rates.
Yeah, if you have some FOMO, what's going on, there is lots of PR coming in, and we're growing mostly because we have many PRs hanging around because we don't know what exactly to do with static pod regression and how to proceed. So we have cherry pick, we have end-to-end tests, we have a couple attempts to fix it. So I mean, some of this some of that growth is expected because we just work in progress. But we also have more PRs coming, and merge rate is not great right now. So I think as people coming up from vacation, maybe we'll kick off speed and start merging faster. I checked closed PRs. There is nothing that rotted away that requires some attention. So this is great. We are not degrading on that, and we are actually paying attention to everything that's coming. All the closed PRs are validly closed PRs. So yeah, if you think you missed something, just check out what's going on, what people are working on. Thank you.
Yeah, thanks, Sergey. The one thing I was just trying to make sure was I thought we got through every enhancement for the 1.23 release that was expected. But if folks feel like there was a gap, please let us know. But I know at least that's where a number of us were focusing. All right, so let's transition to the business at hand here. So Alana, you have the next item here on the static pod regression.
Yeah, I just wanted to put this on the agenda to make sure that there was some visibility and folks were aware of the scope and impact and all that jazz. So this is marked as a critical urgent bug, was introduced in 1.22 as part of the pod lifecycle refactor. And we are, we meaning a bunch of different people, including Clayton, myself, Ryan, Jordan Liggett. I've been working on trying to get this fixed. Essentially, if you take a static pod and you remove its manifest and then re-add that manifest unchanged, then that pod will go into an error state, which is a regression. So, I mean, if you have static pods and you're not touching the manifest, no problem, you'll be fine. But if you do that, then it will cause the pod to error. We don't want that, so we're trying to get it fixed. And it is proving to be relatively complex. And we don't really have a test case to prevent like something like this from happening. So I've been working on an end-to-end test for this. I have something that's definitely catching it on head and in 122, but like passes on 121 and earlier. However, we're talking about like, do we also want to add more test cases to add like more coverage? Is this like exactly the way that we want to shave this yak, or do we want to like approach this test case in a slightly different way, and so on and so forth. So I don't know if we have a working fix yet. The latest that I heard from Ryan was that Clayton's patch might not, the pod probe workers might not restart. Is that right? Ryan, do you want to jump in?
Yeah, maybe. So there is a end-to-end on the PR that Clayton wrote, and I think it's working for the most part. We're running it through OpenShift CI and testing it there as well. And we're getting some flakiness on probes, but it may not be related to the fix. So I'm diagnosing some of that now.
So I just had a question. Like I thought a lot of this came down to UID assignment. So when I was looking at this, I think we were allowing static pods to assert their own UID.
Yes, and the other thing that's a little bit weird is when we calculate the UID of a static pod, it basically only includes like the pod name and like the contents of the file, and I think maybe the node. Or the node name. So like if you don't change that manifest, if everything stays the same, or if you have a static UID set in that pod manifest, from the kubeless perspective, it has the same UID. And so that's causing a lot of the weirdness. But I guess now that that behavior has been in Cube for so long, I think like probably 6 years unchanged kind of thing, I think people will expect this to still work. So I was like, well, isn't that a bug? Shouldn't it just get a new UID if we like delete and recreate the thing? And the answer is maybe not, since people might rely on this behavior and that will break them.
Yeah, that's what I was trying to figure out, was if we knew anybody actually depended on a static UID versus a kubelet assigned UID.
Yeah, I know that some people are definitely using this. Like I think OpenShift was using it at some point. But in terms of like, do we want to continue to support this behavior? I think the consensus, at least from Clayton and Jordan, is that we should. That there's a pretty high risk of breaking people if we go and like change this. So.
Okay.
Because yeah, I asked the same question because we also saw some weirdness in terms of like pod life cycle on static pods, where if you, for example, like restarted a node from like the node's perspective, when it would go and possibly incorrectly update the mirror pod, that pod would transition from running to pending, which is not exactly what we wanted because the UID was the same. So, but that may just in fact be a bug with how the mirror pods get created for static pods and not actually an issue with the UIDs.
Okay. Was there more that we wanted to bring up on this, or is it
Yeah, there was
Ryan?
just the one thing that we wanted to check was to make sure that we had all the right reviewers on Clayton's patch. Like Sergey, do you know if Lantau could maybe take a look at this?
Yeah, I can ask. Lantau is on call, I think. Is he supposed to? Okay, I will double check.
Yeah, sorry, I just replied in the chat. I can take a look.
Great. Yeah, you might want to take a look at the bug as well, and sort of like the discussion on the bug, and that should hopefully catch you up. So, but I included the links to I think everything relevant in the agenda, so you should be able to find that. Not a problem.
Thanks.
I think that's all I had on that one. Just wanted to make sure everyone was aware, and hopefully once we get a fix working, we'll backport it to 122.
Okay, excellent. Well, thanks, Alana. The next item here was looking for reviewers on a new KEP. Who had put this on the agenda and wanted to speak to this?
Hi,
Is this
I
Balaji?
did.
Oh, okay, sorry.
Yeah, I'm speaking for Balaji. Basically, he put this KEP a couple of months back, and the basic, and I'm Manu, and the basic idea was like we wanted to introduce like a way to reject admitting pods based on the node's properties. So for us, the use cases that Fargate, for example, does not allow privileged containers. And if like the Fargate as a compute platform or like technology does not allow privileged containers, and by the time it reaches like Fargate, it could lead to like it's too late. So we would want to like, from a security point of view and also from a usability point of view, we would like to add like pod level handlers, determine like OS level properties, and then reject either by a hard reject or a soft reject, depending upon whatever it is. We would want to try and target it for 1.24. But in general, we want to see like what seems, if this seems like a good idea, as there, and we think like there are other use cases that people like the community can also benefit from. Like recently, Windows introduced the OS spec field, but then you could also like have things outside the pod that you can exec into for different operating systems and determine different properties of different OSS, all the node has to do is like install that particular plugin, regardless of if it's exec or gRPC or whatever it is. I don't know if I summarized it well enough.
No, thank you. I remember Jay and Balaji presenting this concept earlier. So I'm happy to take review, and we can make sure it's on the 124 queue. I guess unfortunately I had missed this for 123. So I'll follow up on that, and we can iterate on the CAP now between then and now. Is that fine, Manu?
Yeah, that's perfect. We were thinking 1.23 was too soon for us also, so 1.24 would be perfect.
I just assigned you, Derek.
Okay. The thing I was trying to recall here was I couldn't remember if Jay or Balaji had talked through, like, what's the desire to deliver this plugin maybe as a static pod itself or outside of a Kubernetes management model, maybe just a daemon on the operating system externalized. Was there a...
I'll take that question, like, because it's fundamentally a design question.
Yeah.
The initial idea, if I remember correctly, was it would reside on the node itself. But I would definitely take that.
Okay.
Question and ask you. I know that for a fact that Fargate does not support daemon sets today. But still, I'll revert back either here or on the CAP itself.
Okay. Yeah. All right. Well, excellent. I look forward to walking through that. And then if anybody else wants to review that CAP or add their use cases, please do. All right. Anything else we want to bring up on that from anybody on the call? All right. Adrian, I think you're up next.
Yeah, hi. I just wanted no. So I just wanted to mention that the checkpoint restore CAP had one reviewer who was more or less in favor of it. I pinged Mronal. He made a review today. He didn't say if he's okay with it or not yet, but I think it's pretty close now.
Yeah, Adrian, so my general feedback on it is like it should, right now it covers all the things we have talked about, like what are all the possibilities, what is the end goal. If we can somehow massage it to like different stages clearly and say, okay, this is the stage one corresponding to your WIP that you have, your proof of concept right now. And if we can clean the one, then I think it will be in a better shape to merge. And I took a brief look at your work in progress, your PR, POC. It looks good.
Yeah.
It's good. It's as we had discussed.
Yeah, the actual code changes, besides the generated CRI API changes, are not that big. The thing I was hoping for, yes. Yeah. So okay, I will talk to you offline about additional changes, and then we probably can. And then I think Dawn was assigned as a approver, then we can talk to her.
Yeah, I think we just need to clean up the CAP a bit to align with what our current plan is. And then,
right. There's a lot of old information in there. That's right. Yes.
Yeah.
I just wanted to jump in because you mentioned that somebody had said it mostly looks good to them. I don't think that person's a Kubernetes org member, so it's good that they looked at it, but they are not the sort of, like, we'd need somebody who's an org member who has like sign-off powers.
Okay, because I think I kind of expected that the person who did the review is the one we added as a reviewer in the SIG Node 123 planning document. But I'm not sure.
I mean, maybe they're an org member and they don't display it publicly,
Okay.
but I think they're in, they work on Istio, but they're not a Kubernetes org member from what I can see. So I don't think that they work on core Kubernetes. So
he
definitely
just switched to SIG Node team. DAO. Yeah.
So the reviewer also needs to be a member or just an approver?
It'll need to get approved by either Derek or Don. We probably also want wider feedback from people working on Kubernetes specifically. I don't know if this is just in scope of Node or if there's other SIGs we need to talk to, Derek.
No, so this is going back to, we had earlier meetings on this, and the staging on this was we wanted to do checkpoint first before restore, and then I think Don had volunteered to just do the review on the checkpoint flow. So I think Adrian will just, Dawn's obviously not here today to speak to her time, but I'm sure together with Renal you can make the increments that were needed. But I don't think there was any major disagreement on the desire to get checkpoint functional. And then we had use cases that we had discussed around like a security analysis where we all agreed checkpoint was useful. So let's just work with Renal if you can on getting the updates that Renal saw, and then we can get Dawn to review as well.
Okay, thanks everybody.
Thanks.
Thank you, Adrian. All right, so then the last topic today looks like a presentation Renal and Marcus you were putting together. You guys want to share?
Maybe just Marcus was looking into splitting of like pod startup latency, and he's done some analysis, and he just wants to present what he has done for and looking for feedback. Marcus, you want to take it over?
Right, yeah, I'm here. Good evening, everybody. Can I grab the share screen, or does anybody else want to share?
Your co-host, you can share.
Cool. Let's see if that works. You're supposed to see my browser. Did that work?
We can see your screen. It is good.
Nice. Okay, cool. So is the font size, etc., good as well?
Yeah, looks good.
All right, cool. So good evening, everybody. My name is Marcus. I'm part of the Knative community, actually. As a quick reminder, Knative tries to build a serverless platform on top of Kubernetes. And one of the main questions to us is, how fast can Kubernetes actually be? So in this slide, basically, if you look at serverless systems, again, as a quick reminder, they try to scale up and down pods as quickly as possible, and even down to zero, which means that if you want to scale up from 0 to something, the pod startup latency is going to be part of the latency of the user. And kind of the narrative and I've worked for different serverless platforms thus far, has always been that Kubernetes is too slow. It just doesn't work. And I got kind of sick of that narrative. So I decided to actually take a whack at looking at things, because like anecdotally, I don't think Kubernetes has to optimize as much as serverless would need, like from their other use cases, seeing from their other use cases. So I was wondering if there was like more, if there was performance left on the table just by looking at it, pretty much. So in Knative, we basically worked around Kubernetes in a couple of ways to get things quicker. One of which is we implemented an exec probe hack, which would allow for your readiness probe to be quicker than 1 second, which is really nasty. We are probing non-ready IPs from our routers to basically also bypass the readiness checks of pods. And then there's a few ideas that are not implemented yet and that kind of don't want to implement because they are like a lot of incidental complexity just because we need to work around Kubernetes as a whole, which is in this case, node local scheduling and pod pre-warming. So the question I asked is that even necessary? So I can we improve Kubernetes itself to drop those hacks and not need them and make the whole community better? And I think, yes, that is very much possible. I looked at it a little bit. There's a cap for subsequent probe granularity somewhere. I couldn't find the link, but I know that somebody has written something up, but we'll not care about that for the sake of this presentation. I wanted to actually look at actual performance improvements on the existing behavior. For example, in kubelet, the CNI scheduler, etc. And I kind of randomly picked kubelet because I was interested in how it works, so I just started there. And all of the pictures that you're going to see right now are all taken on kind. So take them with a grain of salt. I'm mostly using like the numbers to get ballpark-ish numbers, and I'm mostly, at least for now, am reasoning about improvements that could be made by going through them in theory rather than actually measuring things. You'll see in a second why that somewhat makes sense for now. I've written 2 little tools just for me to get an understanding of the kubelet, because the code base is somewhat complex. So this is like pod speed is like spawning pods with a defined YAML schema, just like repeatedly, so it can generate some numbers from that. And then kubelet tracer is what generates the pictures that you're going to see right now. Is basically just using the recently introduced logging. I forgot the term in English. Structured logging. To fetch only the logs that are relevant for a certain pod, so I can like get a look at what the pod's startup latency looks like. And then like one of the things that I noted almost immediately, which you can see in this case, is that even just launching a pod as like it attaches this default volume, like the Kube API did the service account token, and that has a 300 millisecond floor. And if you look through the code as an, I think, arbitrary 300 millisecond retry on a loop, which then spawns another loop, which has an arbitrary 100 millisecond retry, etc., etc., etc. Go down that, and basically that adds up to this 300 millisecond floor, but the actual work taken is only like 10 or 30 millisecond-ish, if even that. So there's an opportunity.
Marcus, can I pause you for 1 second? So
yeah, sure.
If my memory, this slide is very good. If my memory was right, I wanted to, Seth, I think you're on the call. Earlier, we had gone through and explored this, and I think at one point we saw literal sleeps in some of the volume management code. I thought we had pulled all those out. I guess, is my memory bad on that, Seth? And then
no, I pulled out at least one where we were doing like a poll that initially waited at least 100 milliseconds. I'm waiting on the 300 milliseconds. Looks very, very familiar. But yes, there were situations where it wouldn't check to see if the condition was already met. It would sleep and then check. And in a lot of cases, the condition was already met if it would have just checked to begin with.
Yeah, and I think that's correct in this case too, because like the initial check wouldn't be true. I think the problem in this case, I haven't actually cooked up a solution for it yet, but what happens in this case is the volume manager works in that it schedules jobs on pre-created runners. So the runners are basically just go routines per pod, and then they have internal reconcile loops, which are firing only once every 100 milliseconds. And then eventually that you have to go through I think at least 2 steps. One is verify controller attached volume, and then one is mount volume, and they are like individual jobs scheduled to that worker. And I think the solution might be to just introduce like a signal once that worker job is done to actually signal back, reconcile immediately, launch a second worker job, reconcile immediately, like signal that back, and then signal back to the top thing that something happened, and to please double check, something like that. I haven't actually looked at what makes the most sense in this case, but that seemed like reasonably-ish. I think like in this case, I think I've only also written it here, that that doesn't seem to be a signal feeding back from these workers that the worker is actually done. It just waits for it to be done through these retries. And there might be potential to tighten that up.
Yeah, I found that PR from like 3 years ago. I put it in the chat, but I'm sure that there are other things like that in the volume manager.
I mean,
Yeah,
as
on
I
this
was saying,
particular point, Marcus, I think it'd be good to also reach out to SIG Storage, because they're actually properly the owner of the volume manager. It's just our code structure makes it intertwined. So it'd be good to also reach out to some of those folks as well to make them aware of this. What I was curious about was the use case of a representative pod. Obviously, you're getting the service account, so there's always at least one volume, but is the use case you were exploring largely pods with just secrets and config maps, or are you also focused on pods that need access to persistent storage generally?
That's a very good question. To be honest, I'm kind of working my way from the simplest pod possible. And then like if I can find obvious problems, which like this is kind of an obvious problem in that case, I try to fix that, like get that fixed first and then add more to the pod spec. Like the tool I've written, Podspeed, has like basic pods. That is just that. They literally just have one container with one image and that's it. And by the way, I'm assuming pre-pulled images too. I'm kind of leaving that out of the equation for now. And it also can spawn Knative style pods, which then has two containers, one being a sidecar, a readiness probe being set up, etc., etc. I'm kind of working my way up from the simplest possible towards the Knative spec, and then maybe even further, as you mentioned, like config maps, etc., will be in the picture at some point as well. Is kind of the idea. And for what it's worth, this is obviously not an exhaustive list. This is just like the two major things that I've found thus far. I haven't looked, like, as I said, it's not an exhaustive list of the things that we might do. And the second in this case is, as you all may know, the kubelet is largely driven by the plaque, and that plaque has a 1 second timer, which like it kicks it every second. And I think sync pod is only allowed to pass once the plaque has updated its state, like once it's updated the cache. And that causes for some arbitrary long latencies as well, as can be seen in this case here. And I don't actually have a very good, like, it's basically, it comes down to the same quote unquote solution as the first one, is to add more, like to add signals to kick the loops earlier if we know that that it's valuable to kick them. For instance, I've cooked up a very simple thing, a very simple quote unquote solution where actually after this, right before the sync pod exit is called, I poke the plaque to make it like relist immediately. And that drops that would drop this entire 700 milliseconds down to 0, at least for the very simple pod cases. So that's one thing. And that's kind of the whole schema here, is to make things a bit more event driven rather than strictly timer based, obviously where appropriate only.
Yeah, so the one thing on this one, I think I would love to get to an event driven plug. What I'm wondering though is if that will just shift the problem to the runtime. I guess, is there anyone here that has explored this at the runtime layer to maybe think about how it can watch rather than be polled? Because it might still just end up with a 1 second timer there as well.
So on the runtime side, Derek, we could be faster, like because we can use like iNotify to detect stops, and when we do a start, we can check after the start. I think we can be quicker than 1 second.
Yeah, absolutely.
Yeah,
Mrinal. We could do eventing.
Yeah.
'Cause
Actually, I think Kubernetes and Docker already support this kind of event today. And actually, when we worked on Plague at the beginning, we already started looking. We already looked into the Docker events, and it actually worked. It's just that there was some actual work, and at that time, our main focus is to reduce the Kubernetes resource usage and container runtime resource usage, and the release was enough at that time, and that's why we didn't actually finish the complete event-driven Plague. But now, if the latency become a concern, I think it's possible to do that, and I think at least Docker and Kubernetes already support it. We probably need to define like a gRPC streaming based event API, and then in CRI, and then get the event from the runtime.
Yeah, I agree with that, Lantal. I guess I know we're reaching a conclusion here, Marcus, but the other area where I know at least Mrinal and I have discussed where an event-driven Plague would be useful is to just bring down kubelet resource utilization. Right?
Right.
And so there's definitely a lot of benefits for it, because the Plague itself is a generator of a lot of garbage.
Yeah, I'm happy to explore that as well. If y'all think that it won't take 2 years to like augment the CRI API in that case.
I guess like if we don't worry about the Docker shim, like Containerd and cryo maintainers should be able to, if folks from both the communities are like signed up to help drive it, it shouldn't take that long. Like, and Lantau mentioned Containerd already has the events, and cryo is up for adding whatever we need to do to support this.
I mean, it can totally be optional for the runtime, right?
Yeah.
We already have this Plague, which is like
Right.
a brute force Plague.
Yeah.
And we can do like test if it supports it. If not, fall back to this. And if it does, then use event-driven Plague.
Yeah. Even with events, I think we'll still want to do that at a lower frequency, right? The listing.
Yeah, I think we'd basically just want the equivalent of like a normal list and watch controller in Kube, where
right.
we'd get the event and then we would still do a relist with the existing Plague to catch anything we might have missed.
Yeah, or you could do a subscription model where you get the initial and then we'll give you updates to your subscription.
Yeah, till the kubelet restarts or something, when it has to get the state again.
Right.
Yeah, and the as I said, like the very short-term right now solution that I cooked up is kind of kicking the Plague when we know it should have something new. Like in this case, maybe I can show the code here. If that works. Make that a bit bigger. Like I literally just added a poke channel to the Plague, so it can be poked from the outside. And then at the end of sync pod, I'm checking if one of the actions was a start container, and if it was, we kind of know that we changed the runtime state in some way, and hence poke the Plague to relist immediately. I'm not sure if we can also like do a more focused, just list this, just give me that container, or just give me that pod. But for the sake of just showcasing it, this is like brute forcing a whole relist. And that kind of worked, like that improved things. And I guess which brings me to one of the more important bits is how do we actually surface things improved, right? I don't have that here. I have to rely on your guidance to tell me where best to do that. If there's already like dashboards or performance tests that would reveal that.
Yeah, so I think Marcus, when we had met before, if I'm not mistaken, I talked about how we had the node performance dashboard that maybe we could revitalize.
Right.
That wasn't necessarily testing the representative pod that you were presenting here. I think you know, Murnau and I talk a lot lately. He and I were having a conversation before this where it's like, I think we want to be able to get more prescriptive guarantees of like ways that we can measure success. So like what I'm curious about is the answer of I don't want to wait any time, you know, is the ideal answer, I guess. But is there a pod startup budget that you feel what amount of overhead are you looking as reasonable from the Knative community's perspective?
Right. So one definitive goal is to get sub-second, which is, you know, you have to kind of specify on which platform with which networking provider, et cetera, et cetera, et cetera. That throws a whole curveball into the equation. But I'm trying to get sub-second in like, say, P95, something like that. So second is the mark for me right now.
Where that's measured with the Kube API server knowing that that pod is ready, or
that's
just
actually
the
a
kubelet
good
launching
point. That's a good point. I have I don't have a pod speed output here, but generally I'm going via Kube API, yes, because that's like what load balancers, etc. would see, right? To configure networking, etc. To actually use the pod. There's one optimization that we can go for if we run into a wall, which is I'm also looking at time to IP, where I think it's valuable to optimize the time it takes to get the IP into the pod IP into the API server, because that kicks off services and endpoints, which can also kick off load balancer programming. And we already have that thing where the load balancers take non-ready IPs and do use the well-known probe to find out if the thing is already ready, even though the Kube API might not yet know. So that's, I think, a valuable quote unquote workaround. So that's potentially the second time that's worth measuring, at least to us from the Knative community.
Yeah, when I looked at this before, from a kubelet perspective, right, I really, you know, you create the pod, it's admitted to the API server, so you get like post admission time, but then it has to be scheduled, and then the node has to get its watch event and things like that. So when I was doing this analysis before, I would always base it off of like the sync pod add event. It's like from there to when the pod status is updated to running, like how long does that take? Which kind of isolates it to the kubelet and how, you know, what we would have control over in SIG Node.
Right. Yeah, I'm open to suggestions like that. That's fine with me if that's like measurable in a. The main problem is being measurable in a generic case, right? Which is why I started with Kube API visibility, because that means I can run the tool against any Kubernetes cluster and see what the latencies look like in general. But as you say, it doesn't rule out things like kubelet, things like the API being slow, noisy neighbors, etc., etc. I'm also kind of looking at best case scenarios only for right now, because there's I have found enough potential for improvement in the best case scenarios before looking at like things like what happens if you start these pods in parallel. What is there lock contention and things like that? I suspect there will be. But for now, I'm looking at pod after pod after pod after pod after pod, waiting for it to be ready and then launch another one, etc., as to get that to a reasonable pace before looking at scalability, etc. That makes sense.
Yeah, that makes sense. So what I'm wondering is for folks that might be on the call and reflecting on this a little bit, at least I'll put my Red Hat hat on right now, I guess. There's particular resource budgets and maybe density goals that I'd love us to be able to get the community to be able to achieve, which would be, at a particular pod density, how quickly can pods start and stop, and what amount of overhead does a kubelet and runtime provide. I think that's in the best interest for everybody. And so if folks have usage of Kubernetes in their organizations where you have particular budgets that are trying to be met, it'd be great if we could get them shared and talk through and just start measuring our success relative to those metrics, I guess. Some of the stuff I think we've talked about earlier around the density things, I think we're starting to focus on with like housekeeping intervals in cAdvisor and how we get metrics on pods, I guess. So this all just seems to go together well. Maybe that's my last point, which is there an average life expectancy for these pods that you're also trying to optimize for, or is it just 0 to start, but then once it's up, there's not like a churn rate that you're trying to build towards?
Yeah, at least not right now. I have noticed that if you create the pods too quickly, at least right now, the startup times somewhat deteriorate, and I was kind of attributing that to the housekeeping, etc. I haven't digged deeply enough into that code yet, though, to know for sure. But as I said, it's kind of right now, it's the simplest pod possible, and starting it, it's just like getting it ready, getting it to serve, and that's it for now.
Yeah, I think sometimes isn't the model that you keep the pod up and you serve containers quickly, right? To integrate, to do the services.
Sorry, that didn't grok that one.
Yeah, no, I think isn't the Knative model, doesn't it also include keeping a pod up for an extended period of time, but running containers for the services requested?
Not really, no. We kind of use the deployment abstraction even, actually, and just scale up and scale down the replicas of the pod, of the deployment. So we don't do any shenanigans with regards to like updating pods in place or things like that.
Okay, cool.
And yeah, so maybe one sentence towards, I do know that the kubelet code is somewhat diligent. Yeah, sometimes a bit hard to change. So I am looking at the least impact possible. Also with regards to what you mentioned before, I think it's not an option to like make the plaque quicker, like the interval shorter or things like that. I think that's kind of off the table. Looking at actually saving time versus saving time and work versus making more work to achieve a better latency.
Yeah, so Marcus, I was trying to find if we had any past enhancements or documents that had explored the event-driven plague, and I think there's even a document on like the original plague design. I think if you want to help push forward on that, it'd be greatly appreciated, and I'm sure maybe we can start tracking it for a candidate for 124. But I see it as a big win for everybody, independent of the Knative use case.
Derek, I don't know if you saw, Lantau posted a link to an old event-driven stream idea for Docker from 2015.
I think the plague pre-announcement has that design somewhere.
Yeah.
Right, I'll go look at all of these. If anybody has a pointer with regards to the dashboard that you mentioned earlier, that'd be cool. I guess we could like add, I don't know, maybe the simple pod to that, if it's not already a very simple pod, and see how we can make things like get things measured. So I'm not shooting into like, you don't have to trust the numbers that I'm posting them. And other than that, this was mostly supposed to be an introduction, so y'all know who I am, where I'm coming from, and that I'm going to push on that, or I'm planning to push on that if y'all think it's useful. So yeah.
I think like Mike, Lanta, if you guys are interested, we can have a small subgroup defining what the CRI changes can look like for event driven and start working towards putting together a kit.
Sure.
Cool.
Yeah, I've been wanting to help refactor Kubelet Runtime Manager a little bit. That would be nice.
All right, well, thanks so much, Marcus. And if you all do get together, it'd be great to just make sure we all can participate, but look forward to hearing what might come out of some of those discussions. But I think it'd be awesome if we can start looking towards event-driven plague in the upcoming 124 release. I think that got through everything on the agenda. Were there any other topics that folks wanted to raise? Otherwise, I'm happy to give back 10 minutes.
I just wanted to give folks a quick shout out we had the CAP deadline last week, and I was really impressed. I think we got like everything merged and ready to go 24 hours before the deadline, except for like, the one thing I think we ended up dropping. So that was really impressive. Great work, everybody.
Woo.
We did it.
All right. Well, hopefully we're just as good on the execution side of our plans.
Yeah,
And-
on the execution side, I'm going to send out a follow-up email. We had discussed having a sort of like soft deadline to ensure that we had a bunch of PRs up and we were able to track stuff through the release. So I'll send out an email talking about like, we got these beta caps in, so we expect them to merge approximately around this date. And for all of the alpha caps, we expect them to have PRs up by that date. And that way we'll be able to track them a little bit better in terms of what PRs we need to be looking at for feature work this release. So I will send that out hopefully today sometime.
With that, that's a good positive note to end the meeting on. Thanks everyone for joining today, and we'll talk to you all next week. Bye.
Cheers, everyone.
Cheers.